Okay, I want to show you very quickly how to deal with an or statement when you're dealing with probabilities. So this is an example from the practice problems. It says 118 students were asked what type of color their bedrooms were painted, light colors, dark colors, or vibrant colors, and they were tabulated according to gender. So you have on the rows, you have gender, and then in the columns you have the colors. And so if the question asks you what is the probability that a randomly selected person is male or has their room painted in light colors, let's take a look at how to do that calculation. Typically, within the area of probability, whenever you see the word or, okay, or usually implies that you're going to add the categories together. Okay, but you have to be careful because when you add, you have to avoid double counting. And I'll try to show you what that means as we look at this example. Okay, so if you want to look at it kind of from a formula perspective, okay, we would have to figure out how many male students, the probability of being male, or which means add, or the probability of light colors. But then I have to subtract off the probability that they're male and have light colors at the same time. And let me see if I can help you figure out why we do that. Okay, so if we look at the table, okay, and we focus on male, okay, so I'm highlighting the male, there were a total of 48 males out of the 118 students. There were, if we look at light colors, there were 30 students who had their room painted in light colors out of the 118 students. But if you'll notice, the challenge that we have here is we counted this block right here, and let me maybe highlight it in a different way. Okay, we counted this block of 10 twice because I counted them because they were males, but I also counted them because they were light colors. So this block has been double counted. So we have to subtract off that double count. Okay, and then we do the math from there. Okay, so I have 48 plus 30 is 78 minus 10. It's going to give me 68 out of 118. And then we can do the division. 68 divided by 118, and that gives me approximately 0.576 if you round to 3 places. So it'll really help you when you're doing an or if you'll maybe kind of circle or highlight, because then it helps you to see where you double counted. Now in some cases, and I was going to do one for you, in some cases you don't necessarily have to worry about double counting because, for example, if we said what's the probability that a person either has dark colors or vibrant colors. Okay, it's still an or, and again, typically with the or, that makes me think of and or add, excuse me. So we would think about the probability of dark colors plus the probability of vibrant. Oops, I spelled that wrong, didn't I? But we have to subtract, again, we would normally subtract off the probability of dark and vibrant at the same time. So if I'm looking at this kind of from, again, using my colors, we would think dark colors. Okay, and so for dark colors, we had 52 total out of the 118 students, plus those who had vibrant colors. Okay, so vibrant, we had 36. And if you'll notice, there's no overlap there. Okay, so when we go to look at it, vibrant, we had 36, so plus 36 out of the 118. There's no overlap. So what I subtract off is really nothing because there's no overlap. So again, we add together, we have 88 out of 118, and we can convert that to a decimal by the division. 88 divide 118 gives me approximately 0.746. So I hope that's helpful.